Hey everyone. Hopefully this is going much better than last time. I've started to understand a little bit more about YouTube Live, and it is significantly more intuitive when you actually use the interface they mean you to use. I was falling back to the old YouTube Live setup, which is not what they want you to do. So I was not jumping into their new YouTube Live beta thing, and all the links were screwed up. But anyway, things are much better now. I'm a little bit more organized, and I've got that intro video too, so I can actually make sure everything's started up and ready to go right away. Hi, Michael Ficara. I've also got this nice little screen right next to me, which is great because that allows me to actually see the comments and interact with them instead of going minutes upon minutes with a wrong video or the wrong display. So, this episode, let's recap a little bit. Last episode, we went through the deobfuscation of some basic JavaScript-obfuscator obfuscations. That is the first hit when you search for JavaScript obfuscation on Google. This is obfuscator.io. Contains a whole bunch of different options down here that enable you to basically just do weird stuff with JavaScript in order to protect it in some way, or to make it at least harder to understand the intent of. A lot of the things, they look good on the surface, but with a lot of JavaScript obfuscation, it's very, very, very difficult to actually effectively obfuscate JavaScript. So I'm building up a whole suite of utility methods and tools that help me reverse engineer JavaScript. And I've started the stream in order to go through the building up of them over time. All right, so the next step here is going through and reverse engineering or programmatically reversing string array rotation. So the way that looks, so if we take this, and let's see if this actually works properly. Obfuscator.io was down earlier today, and its performance seems to be getting worse over time. So I'm not sure what that means for the state of this website, but we'll see. All right, so we have this string array up here. There's only 2 strings in it right now, so this might not be too exciting. Let's add a few more and see what happens. So let's see. I'm just creating a bunch of strings to add those to that string array so that we can see what string array rotation actually does a little bit more effectively. So last time we focused on reversing the obfuscation of strings because that's one of the core things that almost every obfuscator will do is to protect what the strings are. All right, so let's see what this does. We have no output. That's much less effective. Is this working JavaScript? All right, obfuscator.io might not be the best solution for us to use going forward. All right, well, it's working for now. So let's start rotating the strings. So we see we have this string array up here. It's all the strings that exist in the program in a list at the top so that work can be done on them in one fell swoop. So now if we rotate the string array, so you see here, it's log, hello world, AAA, BBB, CCC, DDD, EEE. So now we're going to be rotating the string array. Let's see what happens. It's taking some time. All right. So now we see that the string array starts with DDDD, goes to EEEE, and it has log, hello world, ABC. So it just kind of shifts the entire array some arbitrary amount every time that you generate it. So we started, so the first one started at log, this one started at DDDD. Let's obfuscate again and see what happens. So now we're starting at AAAA. So every time that you run this obfuscation, you're going to get a different set of string or a different, you're going to get the same set of strings at the start, but they're going to be rotated a certain amount. Obfuscations like this are reasonably effective at thwarting naive reverse engineering tools. And they're actually very effective at thwarting tools that rely on regular expressions. But our task for the next 55 or so minutes is going to be programmatically effectively reversing this over and over again. So let's go down to our workspace down here. We have stage 1, which we went through last time. I'm just going to copy and paste this so that we can have a record of how we actually went through all this. And at some point, I'll clean up all this content and put this together in more condensed videos or some other reverse engineering form so that it's easier for other people to consume. I know not everyone loves this live coding setup. My stomach rumbling. Can you hear that? That's weird. This is a huge mic. I'm not sure if you can see this. It's a Blue Yeti. Works fairly well, but it picks up a lot, which means I can't drink or eat on the stream. Otherwise, you can hear me chewing and doing other weird things. All right, so we have our original here. We're going to stick with this because it's easier and there's no reason not to. It's complex enough where the translations are going to be visible, but not too complex, where the parsing and transformations are going to be a performance problem. That is something you'll have to deal with when doing programmatic transformations of large chunks of code, is that it takes a lot of time to parse and transform all this stuff. So if you're traversing trees over and over and over again, you're going to have to figure out ways of optimizing that. All right, so we have our original. Let's get rid of original obfuscated for now. Let's get rid of obfuscated because that was supposed to be the same thing. All right, this is our obfuscation program. This is what's using JavaScript obfuscator, which is what obfuscator.io is using. And we're running those same transformations locally so that we can reproduce this more easily. What we're going to do for right now is just turn rotate string array to true so that we get what we're looking for. And rather than logging it out, we're going to start writing directly to a file so that it's easier for me to change the file names. So where are we? So we need to write file sync. The first argument is the path, right? Let's see. Original obfuscated.js result. So now new version of iTerm 2 is available. Let's get this. All right, node obfuscate.js. We still have obfuscated. Oh, I was deleting it in stage 1. Why didn't you guys catch me? That's the whole point of this relationship. It's like it's pair programming in front of a whole bunch of people. You should catch the stupid stuff that I'm doing that I'm not supposed to be doing. Oh well. So instead of, I need to set this up with Git. I don't have this set up with Git at all, which is an awful idea. I do have Git set up, so I will git init. Oh, this is here. Oh, this is. So I need to set git init up here. If I do git init in a subdirectory and then go up to a parent, what kind of problems is that going to cause? Michael Ficara, you know. Git add stage 1, stage 2, package.json, package lock, default obfuscation options. Ah, cool. All right, so it does complain at me. I will remove stage 2.git. All right, so what did I screw up? I screwed up, so deobfuscate, obfuscate. So I have the original here, original output. So I need to revert this to, all right, so this is where I wanted it to be before. Now let's go down here, obfuscate, proper directory. Rotate string array 2, true. Do you have a better name than original obfuscated? I ran into problems with my names last time, and I don't feel like thinking about it right now. If you have better ideas, let me know, because I don't feel like thinking about it. All right, so we are going to write our obfuscated code down here. We're going to stage 2. I have a direct message. All right. Stage 2, node, obfuscate.js. So now that should write an original obfuscated. Let's get rid of this one. All right, let's run this through prettier. All right, so our string, it's gonna be hard to tell that our string array is rotated right now, but it is, assure you that. I know that because it has this function right here afterward. This is effectively what shifts everything around. So actually, let's see what's actually happening here. So this is an immediately invoked function expression that gets invoked with a, which is our string array, and this something. We'll see what that is. Let's go through this and console log everything out. Oh, I have this set up with tabs. Oh, force tab widths. How do you set that? So if you weren't here last time, this computer is a burner laptop. It's a research laptop, so it's not set up the way that I would normally have things set up. So we're going to have to occasionally tweak things as we go to things that are more sane. And 2 space indentation is the only sane indentation. Sorry. So console log cd. So this is what gets executed right away. And then we create this function down here. Well, first let's see what that does. So node, I guess node hour. Okay, well, let's first run our original.js to see what it's supposed to do. It says hello world and hello reader. I must have used this for an article at some point. So now if we run our original obfuscated code, which is not what I called it, original obfuscated, stage 2, original, of course. Original, that is not the name that I wanted. So node obfuscate. Do I have this set up to not save on focus or blur? Oh, that's going to be uncomfortable. So I need to save automatically on blur. Autosave on focus change. I guess that's what it's called here. All right. So now we have original obfuscated, node original dash obfuscated. Let's go back to our original obfuscated, format it, go back and console.log cd. All right, cool. So we have our string array, which, well, actually, if you weren't here last time, so these might look super scary and effectively obfuscated. Let's see. If you console log them directly, it removes all potential obfuscation that technique would have. These are just Unicode escape sequences. And like I said last time, this is an example of a pure for show obfuscation. There's no effective obfuscation here right now. All you have to do is log that out and bam, you get all the strings you were looking for. So our original string array is this, and the argument that gets sent there or logged out there is obviously that, because that is just strictly what we are sending in. So we run a function right here with the second argument incremented. So let's check out what happens to our string array. So let's log it here and log it here. So we start off, obviously, with what we're looking for, and then we end up with a shifted array. So this function here, since we're just shifting and pushing, we're modifying this array in line with this immediately invoked function expression, so that once we are right here, we have our original, or we have another list of strings in that a variable, so that all these other calls to it will get the string that they're looking for. So our job, so actually let's log it out here to make sure that what I said is actually true. All right. So we start off with a here. Sync settings extension. That is a really... so our RPit mentions that I should be using a sync settings extension for VS Code, and for some reason I hadn't really bothered in setting up VS Code so that it could be synchronized across a bunch of computers, because I'm really only using one. But that sounds awesome, and that would make this much better. Thank you. I will definitely use that. All right, so console log A. All right, so this is what we start with, this is what gets passed through, and this is what we end with. So we're still referring to, or we're still using this B function, which we dealt with last time, and we're still referring to the same list of strings. Now the list of strings is just automatically rotated here. If we get rid of that, then let's see what happens to our program. Console log. What's broken? Console log B is not a function. Console log B is a function. B is right here. What is going on there? So I just deleted and immediately invoked function expression. And I do not know why it is complaining at me right now. All right, so I get that there. This should be removable without side effects. Why is this a problem? So this, oh, well, it's a problem because we're not getting the right string. So because we've removed the rotation string, let's see what B 0x2 is. So now now I need to actually call that. So it's target. So what I was trying to get, or what I'm trying to call here, instead of console.log is now console.target. So that's what's happening right here, and all these other references are automatically updated to account for that rotated string. So now let's get rid of it, or let's fully account for it. So there are a few different methods that we could use to do this. We could do this, first of all, statically or dynamically, because our environment here is JavaScript, and what this is doing is just modifying JavaScript. We could extract this function out and then modify the strings that we have already extracted via our deobfuscate.js method, our deobfuscate.js script. So we grab that here. Oh, just an update. So shift refactor, it is imminently going to be open sourced. It is not quite there yet. We're just going through the last checks on the list of to-dos before something gets open sourced, and then I'll open source it probably within the next week or a week and a half, and then we'll be able to do this together. I'm going to be at DEF CON later on this week, so I'm not sure if I'm going to be able to get this out within the week before the next one, but it will be out soon. So anyway, we're using shift refactor, which is basically just a query language combined with operations that can act on nodes. So we are already getting this strings array out by referencing the first statement in the program and then grabbing the elements out of the array expression. For those who are confused as to what that means, you can use a tool like ASD Explorer to go through this. So we're going the root node is a script. We're going through the first child there. We are getting, what are we looking for? So we're looking for an array expression there, and we're getting the elements out of there, which are the strings, literal string expressions in this array. So what we could do to deobfuscate this, since we already have these strings, we could just grab the offset and do the rotation ourselves statically, or we could extract that function. We have that function because we have parsed the JavaScript. And we have that available in our AST. We can extract that out with a query method, generate the code for that, and then generate a new script that operates on our strings array in order to modify those dynamically. That, as I say that out loud and I go through that process, that sounds pretty ugly. So let's do this statically. The problem with, or the difference between static and dynamic is that if anything happens or if anything changes with that function, then I'm going to have to change my deobfuscation code. But if I extract that function and then run that function on my data instead of the data in that script, and then generate that back, then it will adapt to how that function changes. That's might be good, might be bad. It's not a good thing if you really can't be sure that that script is going to be safe all the time and you're running this on a machine that you aren't blowing away every time. I don't know, these are decisions that you'd have to make if you were going through this. Let's start off with doing this statically. All right, if no one has any opinions, we will stick to static and move on from there. All right, so we have original obfuscated, deobfuscate. We have our strings. Now we will need is this. We will need this, this number. We'll need to get this out. So first things first, let's grab our new script here and let's check on things. Throw this into ASD Explorer. Let's get rid of our console. Actually, let's rerun our obfuscate script so that we have the unchanged script here. We do ASD Explorer. And now we need to find this right here. So that is going to be an expression statement, a call expression. We're going to need the arguments of the call expression, and we can grab that right here. That is going to be very easy. All right, so let's extract that first. So as I've been playing with these scripts, just in general, I've found that I'm doing essentially the exact same start and the exact same end every time. And thinking of creating a shift refactor CLI, which does very little more than wrap a shift refactor script and with refactor so that you have that accessible at the top level so that we can create these things in much smaller chunks. I don't know, maybe do that. All right, so let's start here. All right, so we're going to have, I'm just saving this down here. I could delete it and then bring it back, but I might just want to copy and paste later. All right, so we have our scripts. Now we're going to need our offset, which is going to be factor.query script. Nth child, I think, is a thing in shift query. Nth child, is it 0 indexed or 1? I don't know, we'll see. Actually, let's see what we get here. Oops. Deobfuscate. No such file. All right, what did I get here? Why is this happening? Oh, because I'm kind of looking for everything there. Interesting. Actually, I can use shift query, original obfuscated script, nth child. So I want the, oh, I did it again. I didn't have this set up. All right, so B, 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 no, F. That's not a thing. Oh, nth child. All right, so variable declaration statement. That is not what I'm looking for, is it? So that is nothing. So it is, no. It is indexed at 1? Really? The reason why that seems wild to me is that first child exists, and for nth child to be oh no, I guess that does make sense. Because first child exists, so that starting by the second child, you have to use nth child, which would make sense. Otherwise, if it was 0 index, then you have nth child 1, which would actually mean the 2, which would just be strange. All right, so that's not wild. All right, so we have an expression statement, call expression. Now we're going to want to get the arguments from there. So we have the call expression, we need the arguments, and we need the second argument. So arguments. So nth child. Is that not a thing? Oh wait, this is what we're looking for. This is what I'm looking for. Why do I have a call expression in there? So I use shift query a lot, but I still get confused sometimes when it includes more than I'm looking for. Update expression. Why is that? So I have the. Oh, is it because of nth child still? Oh, we're getting everything that has arguments? So we have the nth child, so script nth child. Yeah, 1 indexed. So we have the first child of the script, which is this expression statement. Now I need the, oh, because I've got expression here. So dot expression dot arguments. And I still have everything. Compute it. Huh. So I have an update expression on D? Hold on, let's check our script again. All right, so we have original obfuscated here. Let's format that, grab that, bring it over here. We have arguments, literal numeric expression. What else do we have here that has arguments? We have this one. That's where our update expression is coming from. So this is just getting every child that has a dot arguments. Yeah. I'm selecting everything that has these properties instead of just the child. And I can figure out how to make the query a little bit more limited. Michael, if you have a query that'll do that, by all means, feel free to post it in chat. What I'm going to do right now is actually just stick with this and just grab the last one. Because this gets me what I'm looking for, and it doesn't need to be perfect as long as I'm able to consistently reference this. And I can use this to search for, let's see, so out of this, so that has literal numeric, so I have expression arguments. Oh, what I can do is, so I have an expression, literal numeric expression. So I can look for everything that has expression dot arguments and everything that has dot arguments, everything that has a literal numeric expression. All right, I need to practice my own usage of shift query. All right, well this gets me what I'm looking for in a way that I'm not entirely thrilled with. but it gets us going. And that is all I am looking to do right now. So I have my offset here. Now I have this magic number. And once I have this magic number, then I can operate on this script operate on this array in order to shift it myself so that every other call to it is using the shifted array. So now what I can do is, let's see, so I've got my array, I've got this here. What I'm going to do is, so I just need to push shift. So while, why would it increment only to immediately, so it starts at the right point. All right, that works. Well, let's bring this in and play with it here. So we have a function rotate. It takes in an offset. What? So strings dot push, strings dot shift. And now if I add, so let's see if I have rotate offset. So now if I just offset value +1. So this should rotate our string, right? So let's see, console.log strings, console.log strings. Let's get rid of that for now. Node deobfuscate. So now I start off with reader, target, greet, log, reader, target, greet, log. So that is not rotating anything. What is our offset? Offset.value is undefined. It's because it is in an array. And now we should get that. So now let's log our strings. So we get reader, target, greet, log, and then reader at the bottom. So we have a shifted array. This will actually be kind of crazy if this is literally all we need to do to get everything working to deobfuscate this. So all the rest here is the exact same code that we had before. Let's see what this actually does. Look, it works. So this is deobfuscating everything. So we have console.log, the right one there. We have reader, we have world. This is effectively reversing that. We need to get rid of this expression here because this is probably going to break. So let's see. So now deobfuscate output.js. Let's see. So now let's do node output.js. This is going to break because A is not defined. So what we need to do is remove that call expression so that we do not run it. Refactor.delete. So we're going to delete the second child. Throw the output. Run the output. We did not get that. Oh, because it's not the second child anymore. It's the first child because we've already deleted the other stuff. There we go. Hello world, hello reader. So now our output over here is this. Yeah, so sometimes actually this surprises me how easy it is to actually deobfuscate something. So our original here is greeter. This was the original obfuscated version. So we have the strings and the Unicode escape sequences. We have the string array rotation right here. We have the string call. We've got all these codes over here. This is our deobfuscate script. All we've done here is hard code the rotate method and grab the index out of it so that we can rotate our own strings array. These are not the actual strings in the program. This is a list. This is a representation of those literal string expressions from our abstract syntax tree. And because they're both lists and they both are representing the same thing, there's the same number, it's the same order, we can operate on our list of strings the same way that we would, or we can operate on our list of literal string expressions the same way that we would operate on the list of actual strings in the program in order to shuffle them around. So this makes it very easy to do the exact same stuff that would happen in the program statically so that we don't have to go through that work dynamically. So now we have this. We have our deobfuscated script. We've got about 25 more minutes right now. Can jump into another obfuscation. Probably not going to have time for it, or I can take suggestions or questions if anyone else is interested in how something has worked. I know that parsers and ASTs can be somewhat scary for some people to use. I know they actually were kind of scary for me when I started using them because it was this tool that had just an obscene amount of code behind it, so I couldn't understand the code, and it produced a monstrous data structure that I didn't understand. As I started to use them more and play with tools that traverse them and manipulated them a little bit more easily, it became a lot easier to see this as a primary tool for manipulating source instead of relying on something like regular expressions or string replacements, stuff like that. So if no one has questions, then might as well move on to another sort of obfuscation. Or I can show some of the other things that obfuscator or JavaScript-obfuscator can do. So let's see, obfuscate. So identifier names generator. So I have that specified separate from the default. The default I think is hex. So let's see what that looks like. So node obfuscate.js. Let's see what our code looks like now. Original obfuscated. So now our code looks like this. So instead of A, B, C, D, whatever, we have these hexadecimal identifiers. This certainly bloats the size of your script. It makes it a little bit more difficult to just look at this and keep track of what these are because it's just too much data to keep track of. But let's see what our script does. Our script can't run specifically because I am referencing an actual binding name. So let's see. Let's take care of that right now, and then show that we can adapt to things that change. Well, actually, one of the things that I could do. Hold on. So this is part of shift refactor. I'll just show you first. So let's process.exit processing instruction. Process. All right, Visual Studio Code sometimes makes bad decisions with autocomplete and drives me nuts. So process. So I'm just going to press dot to continue writing code, and it's going to autocomplete. That's annoying. If anyone knows how to stop that, that would be helpful because that is just ugly. So process.exit. So refactor.print. So node deobfuscate, let's print that to console. So press escape, obviously. It's little things. And I swear, when there's a lens on and I'm talking, it definitely screws up the brain. So the things that I probably do without even thinking about it just don't occur to me. Thank you, Paul, though. Appreciate it. All right, so we're refactor printing. So I can do refactor dot, let's see, normalize identifiers. So what this does is it normalizes all identifiers in a program. So all it does is make sure that every single identifier in a JavaScript program, it has a unique name, which makes it easier for queries to be written because that way you can specify that identifier name and be sure that it's going to be that same identifier over and over and over again. This is actually very, very useful for static JavaScript that will not ever change. It becomes a little bit less useful for JavaScript that is dynamic. Dynamic in the way of generating different branches of code, different variable declarations, dead code, dead branches, things like that, because that changes the structure of the program, which means that the normalization of identifiers can't be guaranteed to be the same because it will encounter each identifier at a different time, which means that we just might get different identifiers. So for this particular script, since I know it's not going to change, and I know that the obfuscations are set up to be a certain subset of obfuscations, I can be sure that this is a relatively safe thing to do. But for the sake of not using that and assuming that these obfuscations will change in the future, because I hope that they will at some point when we get to a point where we've done more advanced obfuscations, we need to have a little bit more resiliency in our scripts. So we need to find our new variable declarator without referring to the name. So we need to refer to something about the properties of the variable declarator, the shape of its declaration, something along those lines. So let's see here. So we have our script. So shift query original obfuscated. So let's take a look at our variable declarators. So we have a bunch of ugly stuff here. What we are looking for is what used to be B, which in this case is now this function. So this is going to change. We need to figure out something about the function. It's always going to be the the third statement in this program. For the sake of this stage of deobfuscation, just referring to it by index there is probably going to be enough. So let's do that. Paul, yeah, this will be online, so these will get automatically recorded, and YouTube will put them up probably within an hour or so. Last time it took about an hour and a half for it to show up on the videos, but it'll be there. And all this content will get cleaned up and re-recorded in a more formal video at some later point. So output, what am I doing here? So deobfuscate. So instead of looking for this, let's look for the third child. And see if we get what we're looking for right here. So it's nth child, well, let's do it right here. So script, nth child 2. What we want is the variable declarator out of that. And that gets us what we're looking for. So we get a variable declarator with a binding of, is that the binding we're looking for? So 0, 3 something, original obfuscated, 0, 3, 0, 8. So no, that gets us here. That's because I did the second child and not the third child. Or nth child 3. So now I get these, and I need to figure out. So again, brain's not working, part of this streaming problem. I need to figure out how to make better queries so that I'm able to scope it to the immediate level instead of just getting every query or every sub node that matches the last query. That's where CSS queries confuse me. So if you're a CSS master here, you could actually help me, even though it might not look like CSS selectors. All right, so we have variable declarator. I want the first one. Could just get the first one, but I want to write a better query. Variable declarator. So what I want is I want the first variable declarator found. Well, actually, you know what? So I could just get this. So I've been limiting myself to queries, and actually I don't even need to do that because I can just grab specifically what I'm looking for. and just reach down into the tree. So for some reason, that's going to make me feel a little bit cleaner than what I was trying to do. I would like this to be able to be done in a query. I need to practice more with this query syntax before I do that. So nth child, let's go back to ASD Explorer. So we have this node. So we have the variable declaration statement. So we're looking for the first index here. We're looking for declaration, declarators, 0. So console.long log destringify declarator. No deobfuscate. Property 0 undefined. What? So I'm getting what I want there. What's the problem? Declarators, that's why. All right, so now I'm getting the declarator I am looking for. Let's see if this works. Cool. Wait. Oh yeah, no, so this actually works. What I'm doing right here, so I'm not deleting what I want to be deleting anymore. Oh wait, no, this doesn't work. Oh no, this does work. I'm just not changing the variable name, so it looks still slightly obfuscated. And we still have this up here right now. Why is, oh, because I'm not deleting this stuff properly. So I have renamed that and I could delete that. So what I want to do is delete the variable declarator. So that is always the first child. So actually, I could just keep on deleting the first child. And I'll get what I want. Cool. So now I have added the automatic deobfuscation of whatever identifier names have been made. So if they're using mangled identifier names, hexadecimal identifier names, or any other arbitrary identifier names, they can do anything now, and the script makes no reference to identifier names. You'll see this here. There is reference to a binding name destringify right here, but you'll notice, if you remember from the first time, we have renamed that ourselves. So we have gotten this destringify declarator, and we've renamed it ourselves so that we could refer to it later down in the script. Just, I don't know, as an example of how to use rename. This is not part of the original script, so referencing it here is not a big deal. And in order to make it look a little bit more sane, we could do the normalized identifiers at the end in order to make our script look a little bit less terrifying. So this looks very similar probably to the first thing we dealt with, which just got slightly different names because I've guaranteed that everything is the same, or every identifier is unique. So c.log. Oh, haha, normalized identifiers. So I need that JIRA issue. So what I've done here is not account for globals. So I've renamed console with normalized identifiers, which is a bug that needs to be fixed in normalized identifiers. Well, you can tell I don't use that method all that much. So let's get rid of that. All right, so that's our output. And let's run it, make sure it actually works. Node output.js. All right, cool. So now we've dealt with multiple different types of identifier names. Identifiers prefix as well. I think you would be able to easily see past where we are right now to know that we are going to be able to figure that out without much of an issue. So that is something else we don't have to worry about. Now, what else? We are only 10 minutes left, so jumping into anything else right now is probably not going to be that good of an idea. All right. You guys have any questions on the stream? I can tackle some specific stuff. I'm not going to jump into another obfuscation right now because that's going to take too long, and I'm going to forget what I've done. What I'd really love to do at some point in time is to build a partial evaluator within Shift Refactor, so that we could take something like this function and then statically execute it within this partial evaluator, so that we can see how it's modifying values as it would run it normally, without actually running the code. So this would be a much more effective way at extracting chunks of code and reusing that internally, but without the danger of necessarily running arbitrary code. So this would still be walking through each of the expressions and programmatically figuring out what it would have led to via the deobfuscate program instead of running it. So this is obviously something that would monstrously affect performance in a negative way. So we certainly wouldn't do something like this for large swaths of code, but it would be very, very good for determining, let's say, like the value of expressions in like an if statement or something to determine whether or not a branch is ever entered. So as long as you have the values that it's using and you know those values either don't change or change up to a point that you've accounted for, then you could build something like this partial evaluator in order to determine which branches our code is going to take. Hopefully we get there at some point. That'll be a bit of effort, but it'll be fun and it'll be cool. And building a visualization around that would be cool as well for our website, so you can actually walk through code and see what's changing as it works. One of the benefits of using JavaScript to deobfuscate JavaScript is that we can build an evaluator like that much more easily than something like Rust or Go or anything like that, because we can leverage the JavaScript environment to make a lot of decisions that we would have to otherwise code ourselves. So like truthiness or something like that. Rather than codifying all the truthiness logic in another language, we can just have the values that would be compared or evaluated for truthiness and determine whether or not they're truthy in our own JavaScript environment. That's safe because we're not doing anything wild with unknown code, and it saves us a lot of time. So we'll get there. We'll get there eventually. All right, well, I think that just about wraps up this stream. We're a little bit early, but we counted for more than I was expecting anyway, so that's a good time to stop. Thank you very much for joining. Hopefully this stream was a little bit better. If you have any comments about how this looks or feels or is put together on your side, let me know. I have YouTube Live complaining at me that the screen resolution needs to change because it's at 1440 by 900. I guess that's something on my side I need to fix. Maybe that's something in OBS. So I'll address that. Thank you very much and see you next time.